Welcome. In this screencast, we're going to take a look at place values for base 10 arithmetic, which is what most of us do, and we'll take a look at other bases to see how they unfold. And then there will be another screencast that looks at some examples of how to convert back and forth so that you can get some practice with the ideas. So we count in base 10. We count in base 10 because we have 10 fingers, and that appears to be the thing that's most reasonable for us. Every 10, we sort of reset our thinking. We group things in tens. It's natural just looking at our hands. In base 10, there are 10 digits. The digits are the numbers from 0 through 9. They are all of the numbers that can be represented with one symbol in base 10. 10 is the smallest number that cannot be represented with the smallest whole number that cannot be represented with one symbol. Because we work in base 10, all of our place values are powers of 10. There's the ones place, there's the tens place, there's the hundreds place, there's the thousands place, and so on. The ones place, that's 10 to the 0 power. The tens place, that's 10 to the 1 power. The hundreds place, that's 10 to the 2nd power. The thousands place, that's 10 to the 3rd power, and so on. So that in our culture, when we write the number 2020, for example, this 2 is in the thousands place. It represents 2000s. This 2 is in the tens place. It represents 210s or 20. They are the same digit, but because of their place value, they represent different quantities. This is the basic idea behind bases and how they work. There are digits. The place values are powers of the base, and each digit in a number represents one of those place values. But what if we didn't have 10 fingers? What if we had 8 fingers? What if we were like the Simpsons, who would clearly have counted in base 8 if they had a say in it? For, well, 8 fingers. What if they counted in base 8? If they counted in base 8, there would only be 8 digits. And those 8 digits would be the numbers from 0 to just shy of 8. And so how would people count? How would people count in this base? Well, they'd count 1, 2, 3, 4, 5, 6, 7, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 2, 0, 2, 1, 2, 2, and so on. That's the number we call 8. This is the number that we call 18. But they wouldn't call it 18. They would call it 2-2 in base 8. How do we do this? Well, the place values in base 8 are powers of 8. So you have the ones place, you have the eights place, you have the 64s place, you have the 512s place, and so on. Because the powers are 8 to the 0, 8 to the 1, 8 to the 2, 8 to the 3, and so on. So when a Simpson writes the number 2020 in base 8, they mean two groups of 512 and two groups of 8. So they mean something different when they write this number in base 8 than we do when we write the number in base 10. Well, I mean, there's nothing special about them. What if we were only mitten hands? What if we were working in base 4? Well, if we were working in base 4, then there would only be 4 digits, 0, 1, 2, and 3. And we would count 1, 2, 3, 1, 0, 1, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3, 3, 0, 3, 1, 3, 2, 3, 3. Can't use fours, 1, 0, 0, and so on. So this is the number that we would call 4. And this is the number that we would call 10, but they call 2, 2. This is the number that we would call 16, but they wouldn't. They would call it 100. So what are the place values in this base? The place values in this base are the ones place and the fours place and the 16s place and the 64s place and so on, because the place values are powers of 4. Okay? And you can confirm for yourself, this 1 represents one group of 16 and zeros in the other places. This number represents two groups of 4 and two groups of 2. That's 10. Well, what if we were 12-fingered? What if we counted in base 12? In base 12, there have to be 12 digits. There have to be 12 numbers that can be represented with one symbol. So what we traditionally do with this is we use T to represent the number 10 and E to represent the number 11. So in base 12, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, T, E, 1, 0. And this is our number 12. 1, 1, 1, 2, and so on. So this is our number 12. This is our number 14, and so on. What are the place values in base 12? Well, there's the ones place, and the 12's place, and the 144's place, and the 1728's place, and so on, because the place values are powers of 12. Every base goes this way. Whatever the base is, there are that many digits. The last digit is one less than the base. And the place values are all powers of that base. So how do we convert back and forth? That's another screencast.